Okay, I'm making a quick video for a few people that let's make a correction to. I messed up on a video, so I'm gonna make a correction to something that I said earlier on in my last video. All right. When we work a problem like this, I've got a log, and I work this as there were parentheses, and that was, I shouldn't have done that, and I caught it later when I worked the problem down here. So if they want you to take the log of everything, they'll put, this is the log of x plus 21. Otherwise, without the parentheses, it wouldn't be the case. So in the previous video, I worked this, and I had 9 to the negative 9 power equals this, and I was incorrect. What I should have done was, this is log base 9 of 8x, and we always want to clean up everything. Since that's not parentheses, this is just the log of 8x. Okay, so I add 7 to both sides, and I get log of 8x equals negative 2, and that's base 9. Sorry about that. That's base 9. So now, this is one of the situations you have. When you have a log on one side and not a log on the other, you will have all the ingredients you need to solve. You've got your base, exponent, and what that's going to equal. Basically, remember, the log base 9 of 8x is giving me the exponent that 9 is raised to get that. So in this case, I will have 9 as my base, negative 2 is the exponent, and it equals 8x. And so that's 1 over 9 squared, which is, and that equals 8x. Now all of this will be divided, when we divide both sides by 8, okay? So I divide both sides to get x by itself, and so this comes up here. My real answer should be 1 over 81 times 8 is 648. Okay, so I worked some god-awful problem where I grouped all this together, solved it improperly. Okay? And I want to work another one just for some people. Let's see. Here we go. Okay? All right. Again, here is a, remember, e is like a number. It's like 4 to the x, in this case it's 2.718 to the exponent. So here's one of the situations. I don't have a log anywhere. If I can't, so I try to get like bases. Well, I'm not going to be able to get like bases. I'm not going to create anything like e. It's an irrational number. But we always want to, so I want to take the log of both sides, okay? If you don't have a log, try to get the common basis. If you can't, you'll take the log of both sides. And the reason we do that is because it allows our exponent to come down. So I've got, first thing you do though is I want to get just my base and the exponent to something. And then we can take the log of both sides. But first, so we got to clean this up and just get that. So I'm going to add 6 to both sides. Okay, that gives me negative 3e to the 5 minus 8x equals negative 54. Again, I don't like this because I just want I just want the exponential function here. So I'll divide both sides by negative 3. And that works out well because I can't take the log of a negative number. So negative over negative is positive. 54 over 3 is 18. So now I have this right here, e to the 5 minus 8x is going to equal 18. And now, I've got exactly what I want. I've cleaned it up. I'm going to take the log of both sides. This is an exponential function. When I take the log of it, I'll solve for the exponent. Take the log. This is the natural log. You can take the common log. It doesn't really matter. All right? Now this can come down, okay, as an exponent. So now I'm going to have 5 minus 8x log, natural log of e equals the natural log of at. Okay. And I'm going to clean this up here. Okay? So the natural log of e is really e to e, that's 1, right? That's one of our formulas. Log, or natural log of a base to the same base, is 1. What's the power that e is raised to get e? 1. So this I can cross out and just make 1. So basically 5 minus 8x equals the natural log of 18. Alright? I need to get this term by itself. This is 5 minus 8x, or negative 8x plus 5. That's a positive 5. I'm going to subtract 5, and that's now 0. So that's minus 5 on both sides. So now I'm just left with negative 8x equals this, and this is multiplication. So I'll divide by negative 8, divide this whole thing by negative 8, and that's what x equals. And we need to solve for that, and I forgot, but if you plug that in your calculator, remember, that's not the natural log of 13, it's the natural log of 18. That value, minus 3 divided by negative 8. Okay? I think it's 0.26, I think, going off memory. Alright? Last thing I want to talk about for anyone who's not taken the exam. Alright. We've got a few types of problems. Okay? Here's the first kind. No log anywhere, ln or log. Get a common base if you can, like create that 2 squared instead of okay? Rewrite a common base. That can be written as 2 squared to the 7. 2 squared to the 7 is 214. And in this case, you solve for the exponents. Here, how do I get 1? Anything to the 0 power is 1, so that needs to work out to be 0. Okay? And any time, like here, I want to get this base, this exponential function, just b to the x power. I don't want any other, like I don't want a times b to the x power. So let's get rid of this. Multiply both sides by 4 over 1. Remember, we get rid of a fraction, multiplying by a fraction by multiplying by the fraction's reciprocal. So I multiply both sides by 4. Okay, so I can get a common base here. Maybe write 4, so I would do I'd multiply both sides by 4, and I can rewrite 4 as 2 to the squared. And again, when we get like bases, exponents will equal each other. As I move further down, we still don't have log anywhere. But here, so I can't get a common base. But that's when you don't have a log anywhere, get your b to the x power, just like this. This is what you want. A b to the x power, a base to the x power, 7x power. Take the log of both sides. Here I have to clean this up, subtract 6. Other times you have to maybe divide. Okay? Like over here. Here we divide by minus 3 and divide by 3 and then we can take the log of both sides. Okay? And then we're going to have situations like this where we've got the log on just one side. Okay? Alright? In this case, again, I want just this log, get rid of the 6. Minus 6 minus 6, that's 2 equals log base 6 to the 7x. When you have a log on just one side, you've got everything you need. I've got a base, exponent, like I did at the beginning of the video. Base, exponent, and what it equals. 6 to the second power equals 7x. That's 36 equals 7x. Divide both sides by 7. That's your answer. Okay, 5 and 1/7. Okay, 36 over 7 equals x. Okay, and then you get this type of situation where you've got log on both sides, and that's basically, hey, if this log equals this log, and they obviously have the same base, then this has to equal this. Okay, and you solve for x by setting things up, and then on a further the only caveat to some of that would be like this. Again, when we got logs on both sides, this is going to equal this, but first we need to rewrite either the multiplication or the addition or subtraction to get it to be one thing. So in this case, we rewrite addition to be the log of this times this, x minus 9 times x plus 1 equals the log of 24. And basically, this is going to equal 24. This is going to, so that's x squared minus 9x, that's my inner. My outer is plus 1x equals 24. So I don't care about the log anymore. They each equal each other, so this equals this. Anytime you have a quadratic equation, get everything on one side and 0 on the other. Okay, and I also forgot the last thing. Negative 9 times 1, that's minus 9. Okay, so x squared minus 9x plus 1x minus 9 equals 24. So I'm going to minus 24 to get 0, minus 24. Okay? And so what I'm going to end up with is x squared, what's minus 9x and 1x is minus 8x, and minus 9 and minus 24 is minus 33, and that equals 0. Okay? So when I factor that, I know x, I've got plus minus, because this is minus. These last two factors, what are the only two factors that make 33 are 3 and 11, and the difference is going to be 8. But the negative 8, it's a negative here, so I know the negative gets the big number, the 11, okay? And that's going to equal 0, okay? So either x is negative 3 plus 3 is 0, or x is 11. Let's check them out, negative 3 or 11. So when I go in this equation here, let's clean this up. Okay? If I put in negative 3, I get negative 3 minus 9, that's negative 12. That's the log of a negative number. That won't work. It won't work here. Negative 3 plus 1 is negative 2. I can't take the log of a negative number. So that's gone bye-bye, and there's your answer. Okay? So we looked at 3 types of problems. No log anywhere, either like basis or take the log and solve for x. You've got the log on one side. That's where you're going to get base to an exponent equals that. And then you've got log on both sides where you can set, hey, this equals this. But sometimes you have to rewrite your equations. All right? And there'll be another video. Again, this is one I'm putting up now, and then there'll be another one for Sunday night on interest rates. We're going to get into that. Okay? All right. Doing interest, compounding your money, financial exponential equations for finances. Okay, thank you.